This question is titled, How do I effectively extract text according to a pattern? And we're going to talk about capture groups and named capture groups. Because when we think about things like a date example, it's not that just we want to match against a date, it's that we want to match against a date and pull out what the year, the month, and the day was. And so here you can think this is our formulation for our basic regular expressions, just A, B, C. But usually it's something where there's some part of this that we are not aware of, like the date, and we want to extract that. And here's our regular expression for our date. And you can see we have 4 digits for the year, 2 digits for the day, 2 digits for the month, and it matches against this and this. It doesn't match against this, and it matches against this. And we'll also include in this that there's like a date equals. Well, what we're going to do is we're going to parenthesize the portions that we want to match. So we're going to parenthesize this portion here, and by parenthesizing it, we have access to the groups. And so for one of the matches, you can see the last match, you can see that the match objects.groups, and this is what the match object's all about. It's an object that gives you information such as where the match began and ended, the span, and also what are the groups that were captured. Well, here you can see these are all the groups that were captured. It's just the date portion itself. Group 0 is the entirety of the match, and group 1 to the end are each one of the numbered matches. And so you can see here, I not only said, oh, this line happens to contain a date, but this is the date data that it contained. And you can see it extracted the date here, it extracted the date here, it didn't match at all here, and it extracted the date there. Most likely, however, what I want to do is I want to extract the portions of the date. So I'm going to do the same thing. But instead of having 3 groups, 1, 2, and 3, I'm going to name my groups. I'm going to name them year, month, and day, because it's always easier for me to deal with, oh, group year, group month, group day, than group 1, 2, and 3. You know, which is the year? Is that 1? Is that 2? Is that 3? That might be unclear from somebody reading the code unless they knew what the regular expression looked like, and that might be many lines above. So I'll name things. I'll make my life a little easier. And so here's the same thing. I'm matching date space equals space, and then 4 digits, a dash, 2 digits, a dash, 2 digits, and I'm saying this very first portion is my year portion, the next portion is my month portion, and the next portion is my day portion. And you can see it matches, just like before, everything except the single question mark. And I can take a look at group 1, well, that's the year, group 2, group 3, the day and the month, or I can refer to these by name, and my life gets way easier. I can say, oh, give me the mo.group year. Oh, that's the year portion. But note, regular expressions are strings, and the result of the match is a string. It is still my responsibility at this point to convert this into a numerical value. Just like when you're dealing with CSV data, you either have to hope that the tool you're using is smart enough to do the conversions for you automatically, or you have to do the conversions manually. But regular expressions are about matching textual data. If that textual data happens to include numerical data, you're responsible for performing the conversion from textual data to numerical data. You're responsible for doing ints and floats to numerics and so forth and so on where relevant. Here, I'm going to try matching something that happens to have a set of parentheses to the left and the right of it. And so here I'm going to match a value plus some error bound, like a plus or minus. And I'm going to do this in pandas, and I want to show you something really neat that you could do in pandas. If we have a series that contains this data, 3 dates and then some value, and each one of these values have this, and I want to extract that, there is a method, .extract, that's under the string namespace that allows you to extract data from your regular expression. So I'm going to say match anything here, and you can see it extracted this into a pandas data frame where the columns of this data frame are the numbered matches starting from 0. So here I could say, okay, match anything with a space and then anything else with a space. And you can see, oh, it matched 0, it matched the 1, 2, 3. I didn't match the 4, 3 by itself, but it matched the 2, 3, and then it matched the other portion. Well, I'm going to make this a little bit more sophisticated. I want the part that I match from the second part to not include the parentheses. Because parentheses are for capture groups, I have to escape them. So you can see, okay, it removed the parentheses from my match. Very good. I don't want to include in the match the plus minus portion, so I'll put that outside of my capture group. I want to name these capture groups. So this is the number, and this is the error. So there we go. Pandas knows that these are named capture groups, and it uses those names for the column names. Great. Well, actually, you know what? I want it to match either with the error or without the error. So what I'm going to do is I'm going to allow this group here to include the space, and I'm going to make it optional with a quantifier. Oh, let's do that one more time. So here we go. Now let's include, oh, and the space needs to be included. Oh, the space needs to be included, not before the parentheses, but with another grouping like that. And now let me make this optional. I can group these things in order to make them optional, but that's kind of ugly, and I actually need one more piece for this. And by the way, the one more piece that I need is I don't want this superfluous match to show up, this superfluous match matching this group, but in order to get this working, let's just do that. Let's match any number of space characters, and let's see, do we have anything here? Oh, and critically, we'll talk about this. This is a little bit too greedy. I'm going to make this just any number of digits and any number of digits. Okay, it seems to have extracted things. You can see it extracted the 1, 2, 3. It extracted the 2, 3. It extracted the 2, 3 and the 10. It extracted the 4, 3. It had this extra group that I didn't care about. This is still string data, so I do need to grab the 2 columns that I care about, and I do need to do a to-numeric on this to turn this into actual numeric data because it's still string data, and probably because it's integer data, I need to make this like an int array, something like that, but you can see I did the match. Now that extra superfluous group is being caught, and maybe I don't want it to be caught. And so what I can do is I can tell this regular expression, do not capture this group with this syntax. The question mark colon means a non-capturing group used only for grouping purposes in order to make the match work. And so without that question mark colon, you can see this is what I have. With the question mark colon, it no longer has that extra superfluous match because that parentheses is just for grouping purposes. And so if we take a look at this, we can think this here means any number of digits, and then I'm capturing the digit portion at the end. Well, hold on a second. This means I'm capturing digits, but it doesn't include that these values could have parentheses. So I really need to escape these parentheses. And to really get this working the way I want, I need to capture the first set of digits and the second set of digits, but that creates too many groups. And so what I want to do is I want to make that first part a non-capturing group. And so the only capturing groups I have are this here and this here. And rather than have these as unnamed groups, let's make these named groups. Here we go. And you can see I've just tightly grabbed just the pieces of the data that I want, the 1, 2, 3, and here I'll make this 4, 5. And this works whether or not I specify that error bounds here. If I don't specify the error bounds, I don't get a corresponding group for the second part. If I do specify it, I do get a corresponding group. This is a non-capture group. Now, here's where it gets a little tricky. We cannot specify a named capture group with the same name more than once. So I can't say, oh, capture A, B, C, and D, E, F, and this one is called A, and this one's called A. It won't let me do it. I can't specify a named capture group with a name that is not a valid Python identifier. So I can't say, oh, this group is called 0. That's not allowed. Here, I can't use a period, but I can use an underscore because that's a valid Python identifier. So one of the limitations is these named capture groups, at least in Python, have to be valid Python identifiers. Where this runs us into a little bit of trouble is, if it's the case that I want to create a very complex pattern via string operations by building up a big complex string, how do I do that? Well, if I do that with named capture groups, those named capture groups are inevitably going to collide. I'm going to have 2 named capture groups with the same name, and the regular expression is going to bite me. So one reason why I do compile ahead of time, just to make sure that the regular expression is valid, because compile is what's going to spit me out an invalid message if this happens to have some violation of the regular expression grammar, not the underlying operations. This is one reason why we might compile ahead of time. Now, here, what I have is a value pattern. It's some value plus that error bound. And what I'm going to do is I'm going to try and match against 2 values, x equals something and y equals something. And I'm going to do this by composing these strings. I'm going to specify not the regular expression, but just the pattern itself. And then I'm going to build a regular expression by saying x and then an equals and then the value pattern, y and then an equals and the value pattern. And I'm going to join them with any amount of white space, 1 or more white space characters. And one small trick I'm going to do is when I specify this value pattern, because it's a Python string, I could put a placeholder character for the namespace of this, and I could fill this in. And so if we actually look at the regular expression that I generated here, this is maybe one way, a little bit clumsy, but maybe one way that we might get around the core of this problem. Here you can see this is the regular expression that I built, and this capture group is called xval and xerror, and this capture group is called yval and yerror. Now, this is another regular expression flag that I'm using here, verbose. Verbose ignores any white space in the regular expression, which allows you to put it on multiple lines with comments. So here you can see I'm matching x and then any space character equals, and the numeric value and an optional error, a numeric value and an optional error. This will match either one of these two possible candidate strings, the one with the error bound and the one without the error bound. Let me comment this out so you can see. So here you can see it match that. And if we take a look at the match groups, you can see that I managed to match those two groups. But because I can't rename those groups, I need some mechanism to make sure those names are distinct. And so I'm going to use some simple name spacing mechanism. Is that a great way to do this? No. And this is one thing that you have to be careful about when you use regular expressions, and one reason why you might be forced to use find iter, because if you have a common thing being matched over and over and over again, this name spacing is very clumsy, and this is something that you might just once in a while do ad hoc. You can't have the same name capture group more than once. And so eventually, if you want to match that same portion of that pattern in multiple places, you're going to have to find some way to distinguish them. Find iter is probably a better solution, and what might be a better solution is to first use a regular expression to whittle down to what you want to look at, using like a full match, extract a bigger chunk, and then from that bigger chunk do a find iter to find each iteration. This name spacing, I think, is too clumsy, but it is an option if you need it. Now, here you can see one final thing that I can do with the regular expression. I can put comments in it. I don't know that this is that useful. I think the verbose flag is much more useful, but a question mark and a hash in parentheses is a comment in a regular expression. It's not part of the pattern, and you can see this just matches ABC, and the comment is just there. Is this that useful? No, because imagine if this is a very long regular expression. There's comments right in the middle. I think the verbose mode is a lot easier to actually use than this, but it's an option that you have, and maybe there are some circumstances in which you might find that it's useful. Bear in mind, if you put a space here, the space is part of the pattern, not part of the comment, and it's not going to match this text anymore. But there you go.